Alright, welcome everyone. In this video we're going to do a 14.3 problem. That's going to be about partial derivatives. I'm here on exam 1 in 2015, looks like the fall semester. And here's our problem, right? So we have a nice two-variable function. We would like to find a couple, it looks like second-order partial derivatives here. So we're going to take this one step at a time. Let's figure out the first partials. So again, this notation here, it means take the partial derivative with respect to x and then with respect to y. So let's go ahead and calculate out, if I was to take the partial derivative with respect to x, what would happen? So let's see. Again, I'm thinking that y is constant, right? So y is, it's along for the ride here. So let's see, if I was to take the derivative of x squared, that 2 would come down and I'd get 10x, and the y is along for the ride. And now, okay, natural log of 2y is, again, it's along for the ride here. So I'm really looking at this x to the negative first power, right? It's in the denominator, so that's x to the negative first. If I was to take the derivative of that negative 1 would come down, cancel with that other negative, and then I would get x to the negative second power. So that's going to be dividing by x squared. And again, that y stuff is along for the ride. So the natural log of 2y. And there we are. Alright, now, so if I would like this first answer, I need to then take the partial derivative of this with respect to y. So g of x, y. So now I'm thinking that the x's are constant. They're along for the ride here. So, okay, if I was to take the derivative of y cubed, let's see, the 3 would come down, and then I would reduce my power by 1. So I'd get y squared. Again, the x is along for the ride there. Here I'm dividing by x, but I might as well be dividing by like 5, right? Or dividing by 5 squared, 25, or something like this. Again, it's along for the ride. So if I was to take the derivative of natural log, well, that would be 1 over the inside. And then don't forget about the chain rule here. So the chain rule says I need to multiply by the derivative of the inside. The derivative of 2y is going to be 2. And again, that 1 over x squared is along for the ride here. So, okay, there's a little bit of cancellation that happens. And so when I write my final answer, I'll simplify a little bit. That'll be 30xy squared, and then plus, and I have 1 over yx squared. And there's my final answer. Alright, in the second case, let's see, I need to calculate out g of y, right? So I'm going to calculate out g of y first, or sorry, I mean the partial derivative of g with respect to y, more formally. Okay, and then I'm going to do the second partial, both with respect to y. Okay, so again, I'm starting back here at the very beginning, taking the partial derivative with respect to y, thinking about x as constant. So I'm going to have 15x squared y squared. And then again, I'm thinking as x is constant, I'm dividing by 5 or by 2 or by whatever, right? It's constant. So when I take the derivative of natural log, I'm going to get 1 over 2y. Don't forget about the chain rule. And again, this 1 over x is constant. It's along for the ride here. So again, there's a little bit of cancellation that happens. Okay, so if I was to then take a second derivative, also with respect to y, let's see, it looks like I'm getting 30x squared y. So similar to this other one, but not exactly the same. And then if I take the derivative here, again, the 1 over x is along for the ride here. If I'm taking the derivative of y, right, this is y to the negative first power, so that negative's going to come down. It'll cancel with this other negative. And so I'm going to have 1 over y squared, right? So that negative 1 comes down, and then it gets y to the negative second power. Y to the negative second power is the same thing as dividing by y squared. All right, so my final answer here is 30x squared y plus 1 over x y squared. So it looks like just the powers seem to have jumped a little bit. All right, that is my final answer, and that's all there is to this problem. Just have to really be careful and make sure that, okay, first of all, there was some kind of tricky chain rule here, and also making sure that you really have a good handle on leaving one of those two variables constant, either the x's or the y's, and applying your derivative rules. All right, hope you guys enjoyed. See you next time.